Hello everyone, now I'm ready with my second video. As I promised you, I'll be discussing few questions what we did in last video, that is the combination reactions and decomposition reactions. So here first question, and there are a few important questions, I won't be taking all the questions. A solution of substance X is used for whitewashing. It's an NCERT question. Substance X, it is used for whitewashing, right? And you have to name this substance and you have to name this chemical compound and give its chemical formula. And next is, if this X in this question reacts with water, then write a chemical equation for it. So I have to write a very to the point answer. The first answer is the part, it is a salt compound, calcium oxide. Calcium oxide. So it's coming, and have to write the name calcium oxide, right? And this is a chemical formula and this is its name. And second part of this question is, how does this substance X reacts with water? So it is calcium oxide plus water. You remember this is a combination reaction. Calcium oxide plus water gives us calcium hydroxide and it is aqueous, right? And we get it. Now what happens here is, you just see it's balancing. 2 hydrogen atoms, 2 hydrogen atoms. 2 oxygen, here 1 and 2 oxygen. And calcium 1. So equation is balanced. And this is one of the NCERT question. Now next question what we are going to do is regarding it is related to decomposition reactions. As we have done few. Now first I will take up, so before that, one thing I want to discuss, how to test this carbon dioxide gas. Now this calcium oxide, in vernacular language it is known as tuna, the white powder we use it. When we dissolve it in water, we get the white solution that we use for whitewashing. Clear? Now what do we get? We get calcium hydroxide. So actually the person, the painter who comes for whitewashing in our houses, he dissolves this in water. And in the bucket, that white solution, white powdery solution what we get, it is this calcium hydroxide. And this reaction is exothermic reaction. Lot of heat is evolved because in practical use, when you take a lot of calcium oxide, that is tuna, and dissolve it in water, and the painter will definitely say to you that you cannot put your hand into it. It appears to be a boiling solution and it takes some time to get cool. So it's an exothermic reaction and it is a combination reaction also. Two things. Combination, 2 compounds combined to give you a single compound, and next is lot of heat is evolved, not water, sorry, it's heat. Lot of heat is evolved, so it becomes exothermic reaction. So what do? We are dissolving this in water and we are applying this, that is calcium hydroxide, on the balls. But what happens next? This calcium hydroxide, when applied on the wall, it reacts with carbon dioxide present in the air, right? That's a very beautiful reaction. So what happens? Again, this is a combination reaction. It will combine, not combination, it's a precipitation reaction. You will get calcium carbonate and water. So after 1 or 2 days, what you find on the walls, it is a calcium carbonate. Isn't it amazing? You dissolved one compound, you got another after reaction, and when it was applied on the walls, it reacted with carbon dioxide, and next after 1 or 2 days, we find that the walls are more bright. It is a calcium carbonate that has been formed on the walls. So this is very important practical concept also, and important question also. And next question is regarding the decomposition reaction. So what type of questions you will be getting? Say, first example is the spirit lamp. Then the test tube is here, and in this test tube there is a green color salt named A. After heating, when you heat this, what you will get, there is an evolution of gases, that is B and C, and they have a smell of burning sulfur. Keep noting down the clues. Then what happens, on heating A, you get a salt. This color is green. On heating it, you get D, which is white in color. And on further heating, you get a compound E, which is brown in color. So what the question is, identify A, B, C, D and E. And also you have to give the reaction, its time, and also you have to give the equation, well-balanced equation. So understood the type of questions? So by the green color, last video we did all the decomposition reactions. So you must remember that we did ferrous sulfate, heating of ferrous sulfate, heating of lead nitrate, heating of copper sulfate, and heating of potassium chlorate, heating of calcium carbonate. But if the color is mentioned, so it is ferrous sulfate. You remember that we did it in two parts. If it is green in color, it is ferrous sulfate with 7 water molecules. So we call it as hydrated ferrous sulfate. Hydrated ferrous sulfate. I am not removing this so that we can get to know what the question is. On heating, so green color salt is A. One answer is given. On heating, first it turns to white, so ferrous sulfate, and water molecules, they are expelled out and they collect here at the neck of the test tube. So this is the nothing but the water of crystallization that has been evolved during heating. And next is this color salt, this is white, and here the question part was identify the salt D. So what you will write, anhydrous. Are you getting it? Anhydrous ferrous sulfate. And this is white in color. So the answer to the part, this part, that is D salt is anhydrous ferrous sulfate. Now we are going on further heating. I'll write it over here with a different color so that you can understand. This salt on further heating, FeSO4, ferrous sulfate, which is white in color. On further heating, what you will get? Ferric oxide, Fe2O3, with the evolution of two gases, SO2, that is sulfur dioxide, and sulfur trioxide. You remember this reaction? So the gases, we know they have a burning sulfur smell. So here the answer to the B and C is sulfur dioxide and sulfur trioxide. Now what they ask? Name the compound B which on further heating it changed from white to brown. So answer to E part is ferric oxide. You have got formula also and you write the name also. Now here we are going to balance it. 2 iron. Now again hit and trial method. Oxygen. Here 4 2s are 8. 3, 4, 5 and then 8. 8 oxygen. Sulfur 2. So this equation is balanced. 2 sulfur, 5, 8. Yes. So this equation is balanced. And next question we are going to discuss is another salt. Now what you have to see is the clues which are given in the question. Again a test tube. I'll just draw the representation. This is test tube. This arrow head indicates the burning sulfur. So we are heating the salt. I'm just white. So copper sulfate, reject that. Ferrous sulfate, reject it. What salt we can expect? It could be lead nitrate, it could be potassium chloride, it could be calcium carbonate. But let's see another clue. The salt is white in color, named A. After heating the salt, we get the gas which have brown fumes. So brown fumes, which salt we did? And if you remember, it was lead nitrate. It is lead nitrate, right? PbNO3, and this is twice. And this color is white. So the answer to this part, salt A, is lead nitrate. You have to write name also. I'll write it for you. Lead nitrate. Clear? On heating lead nitrate, you get lead monoxide plus brown fumes of nitrogen dioxide and of course oxygen gas. But here we can say the question part for this brown fumes, name the gas or name the compound B. So B is nitrogen dioxide. You have to write name also. Nitrogen dioxide. And how to answer this? You can draw this diagram in your answer sheet, and here only in B here you can write this answer, A you can write this answer, and next part of the question is identify the reaction and write the equation. So reaction is the decomposition of lead nitrate, and you have to give the name also. This is a decomposition reaction. Decomposition reaction. But yes, since we heated it, so it's a thermal decomposition reaction. In last question also I feel we missed it was type, the part of the question was the type of question, that is ferrous sulfate decomposition. There also the answer should be thermal decomposition of ferrous sulfate. So type of reaction was that. Here also the type is thermal decomposition. So is it clear? Next question is, if a blue color salt is heated, if the salt is blue color, and what do we get? Again the test tube. This diagram may be given in the question paper, because why do we insist on such type of questions? These questions are mentioned in NCERT question, in the NCERT book, in the form of activities, and questions are asked indirectly from those activities also. So you have to concentrate especially on the activities given in the NCERT book. So I am taking up those questions only. So again, if the blue color salt A is heated, and on heating, it is heated in a dry boiling test tube. Other salts are also heated in a dry boiling test tube. What is the idea by saying dry boiling test tube means? On heating, when we get water molecules over here, it means the test tube was dry, water has been expelled out or given out from this salt. So it is hydrated salt. You are getting the clue. And this blue color changes to white in color. That name the compound B. Now this next part of the question is, from where does this water molecules come from? You have to give the reason. I am writing the question in the form of clues. So, and identify now the reason for water molecules, and next part is give the type of chemical reaction. So we can identify this blue color salt as hydrated copper sulfate with 5 water molecules. So this is the answer to part A. Salt A is copper sulfate, that is hydrated. It is also known as copper sulfate pentahydrate. So I write it is hydrated copper sulfate. Pentahydrate, I will not write that. Simple hydrated, it means 5 water molecule. Color is blue, and on heating you will get copper sulfate. Then if you go in different steps, it is if at 100 degrees centigrade if you heat, you get copper sulfate with 1 water molecule. You don't have to go in detail, but for knowledge sake I am giving it to you. So if we heat this copper sulfate further at approximate 230 to 280 degrees centigrade, now you will get copper oxide. Since it is a decomposition of sulfate salt, you will get SO2, SO3 and oxygen molecule. So we will balance it, but here I will not concentrate on balancing. Main thing is this: the blue color salt changes to white, it is copper sulfate, right? It is slightly bluish in color, but one step counts, that is, it is copper sulfate. First we get copper sulfate also here. I'll just repeat it now. I'll repeat it. Copper sulfate now slightly bluish in color. On further heating, temperature is 230 degrees centigrade to 280 degrees centigrade. First it changes to copper sulfate, again with expulsion of water molecule, and then if you heat it further, then what do you get? Copper oxide, then sulfur dioxide, and oxygen. But our part of question is name the salt B. It is copper sulfate anhydrous. There is no water molecule. Now another part of the question is, since the test tube was dry boiling test tube, from where does this water molecules came? At the neck of the test tube. So answer to this question is, we heated hydrated salt, 5 water molecules as a water of crystallization were attached to this molecule. So on heating, the first thing, the salt loses this water. Not immediately, because one water molecule will remain attached to it, so it will very slightly bluish color. But on further heating, you will get completely hydrated salt first at it's a transition state. So this white salt is nothing but it is anhydrous copper sulfate. Anhydrous copper sulfate, CuSO4, and its color is white. But I'll tell you one more thing. If you keep this test tube with this salt, don't heat it further. This I just gave you for the knowledge sake how to heat it further. And remember, I am not balancing this equation since we have done it before. So I won't waste time over here. If we keep this test tube with white copper sulfate, that is anhydrous copper sulfate, for some time in the atmosphere, it will again turn blue. How? Copper sulfate, it will absorb moisture from air and it will turn, if I write like this, blue colored salt. Blue colored salt. Crystals will not form, because that of course we can do it with the method of crystallization. So it will absorb the water. So what does it mean? This water of crystallization is responsible to impart color to the salt if the salt is colored. That's clear? Now, next question we are going to discuss again from the decomposition topic. You may be given a diagram. We have drawn it earlier also. From diagram you can understand. Here we are giving the provision for 2 electrodes. This is the battery, positive and negative terminal. Here there are the 2 electrodes. And what do we do here is, we will fill this beaker with water. Water is acidulated, means few drops of acids have been added to it so that ionization becomes easy. And we have to invert 2 test tubes filled with water above this. Now what the question part is, this is gas A at cathode terminal and this is gas B. What the part you can understand, you can guess the question, name the gases A and B given in the above diagram. It is electrolysis of water. Electrolysis of water. Then next part of the question is, why the gas B is double the amount as compared to the volume of gas A. Then third part, name the type of reaction and write a complete balanced equation for the reaction. Now it is clearly indicated from the diagram itself, whether it is given in the question or not, it is understood that it is electrolysis of water. So the gas A, so let's write equation for electrolysis of water, and you must remember that once you write the equation, all the questions will be answered very easily. So water, it's liquid, electricity is passed through it, this diagram indicates, you get hydrogen gas and you get oxygen gas. Balance this equation, oxygen 2, here we have to multiply by 2, it becomes 4 hydrogen atom, here also 2. Now what do we get? 2 gases. Now this which is A and which is B? Oxygen it is a oxide ion, negative ion. It will be at anode. So at anode you get oxygen gas, and at cathode negative terminal hydrogen ion, first it will go here as an hydrogen ion and 2 hydrogen ion combined will form 1 hydrogen at molecule. Is it fine? Now this will be at cathode. So this is anode, positive terminal, and this is cathode, negative terminal. At cathode you get hydrogen, so gas B is hydrogen gas. The answer is clear from the equation. And gas A is oxygen. Now next part of the question is, why the volume of B is double than the volume of A gas? As you can see, what you have to give the answer. As we see from the equation, on electrolysis of water molecule, we get 2 volumes of hydrogen and 1 volume of oxygen. So it's a double. And another part you can also, same part you can explain, in water molecule, we have got 2 atoms of hydrogen, 1 atom of oxygen. So we get gases on electrolysis of water in the ratio of 2:1 by volume. Do remember to mention by volume, because by mass it becomes 1:8. So this part of the question is also clear. Next part of the question was, give the complete balanced chemical equation. So balanced chemical equation we have given, and the type of reaction. Type of reaction is electrolytic decomposition. I'll write it over here. It is electrolytic decomposition, means the decomposition reaction using the electricity. So this question is also clear. Now another important question is, since we have done combination and decomposition reactions, so why decomposition and combination reactions are opposite to each other? Question can be formed in asked in other form also. Justify the statement that combination reaction and decomposition reaction, they are opposite to each other. So it's I'm just giving you the clues and how to write to the point answer. Combination, as the name indicates, 2 single elements or compounds combine to give you a single compound. So, hydrogen and oxygen on combustion means when hydrogen gas will burn in the air. So, here we write combustion combines to form a single compound, water. So, balance it, 2, 2. Here oxygen 1 and it is 2, and here also we have to do it like this. It's balanced combination. Here decomposition. Decomposition is just the opposite to combination reaction. It means splitting of single compound into 2 or more. Here combining 2 or 3 to make a single compound. And in decomposition, splitting of one single compound. See, single compound with the use of some energy. Here we are using the electricity. You get 2 or more compound. So here we are getting hydrogen and oxygen gas. Is it clear? Now balance it, 2, and here 2, balancing with oxygen. Hydrogen becomes 4. And here also hydrogen becomes 4. I am not concentrating more on balancing, but I am doing it hurriedly since we have done it before also. So can you see, now you can clearly write, it is very clearly evident in the above example that combination reactions are opposite to decomposition reactions. You just have to write few words if you don't write complete sentences. Combination means from here only, combining 2 or 3 elements or compounds to give a single compound. And decomposition means using energy in the form of electricity, heat or sunlight. Single compound splits, breaks, decomposes into 1, 2 or more than 2 elements or compounds. So it's clearly evident they are opposite to each other. But remember, you have to support your answer with example. So this is a very easy and simple example to remember it. You can remember it as a combination reaction also, and you can remember it as a decomposition reaction also, and you can use this combination and electrolysis of water in answering this question also. So another question, that is, what is the importance or use or uses of decomposition reactions? Uses or importance of decomposition reactions. Decomposition reactions. So very clear is, we have done the decomposition of silver chloride, silver bromide. The decomposition of silver chloride or silver bromide is used in black and white photography. Black and white photography. This is the clue for if any question is asked from this. I will be discussing after this. Next use of this is extraction of metals. That is sodium chloride. You remember when we do electrolytic decomposition of sodium chloride, that is when we pass electricity through liquid, that is molten sodium chloride, you get sodium at cathode terminal, negative, because metal is there, positive ion. Then chlorine gas at anode. So you have to balance it also, 2 here and 2 here. Fine. So this sodium is extracted from sodium chloride. So this decomposition reaction is useful in metallurgical operations, that is extraction of metals. Another example we can take alumina, that is aluminium oxide. Again it's molten, pass electricity through it. You will get at cathode the aluminium metal along with the evolution of oxygen gas. You can balance it, 2 aluminium atoms over here, 2 aluminium atoms. So it's 3 multiplied by 2. So you get 3 2s are 6 oxygen, 2 3s are 6 oxygen. Here aluminium becomes 4 atoms. And here again we'll have to make it 4 since it is an hit and try method. So decomposition reactions that is photolytic decomposition, that is in the presence of sunlight or any other light, of silver chloride or silver bromide used in black and white photography, and electrolytic decomposition of molten salts of oxides of aluminium and of chloride of sodium. You get the metals, the corresponding metals. So two uses we can say. And another also, all the digestion of food, that is protein into amino acids, starch into glucose, all the digestion process, digestion reactions which take place in the presence of enzymes, they are also known as decomposition reactions. Now another thing, important feature of decomposition reaction, the question is asked, prove or explain or justify the statement that all decomposition reactions are endothermic reactions. They are endothermic reactions. How? First thing you must know, if we know that endothermic reaction is which requires or which absorbs or which uses energy to carry out the reaction. Such reactions are endothermic reactions. And decomposition reactions are taking up energy in the form of heat, in the form of light, or in the form of electricity to carry out the chemical reactions. So all decomposition reactions are endothermic reactions. Only 2-3 lines. Example you can take, say, for splitting the water molecule into hydrogen and oxygen gas, we require energy in the form of electricity. Balance it, 2, then this 4. Is it okay? One example is sufficient. You can give another example also. Okay, let's take silver chloride. If silver chloride is exposed to sunlight, we get a grey color compound, that is silver, and chlorine gas is evolved. This arrow indicates evolution of gas. This is a white color salt. Again you balance it, 2 and 2. Is it fine? Yes. So last question in combination and decomposition reaction to be discussed is, again, there is a salt in the china dish and the color of the salt is white and it is exposed to sunlight. It is exposed to sunlight. So sunlight is coming. After some time, the salt in this china dish changes into a grey color powder, right? And what happens? Now the question for this is, name the white salt A and name the compound B and give the type of reaction and chemical equation also. As the sunlight indicates, sunlight is when which salt is exposed to sunlight, that is photolytic decomposition. It is nothing but the silver chloride, AgCl. You can also write silver bromide also. Clear? On exposure to sunlight, it decomposes into, if I write like this, silver, which is grey color powder, and with the evolution of chlorine gas. Balance it. If I take only sodium chloride over here, then it is chlorine gas. If it is silver bromide, then silver chloride, then it is chlorine. And if it is silver bromide, then the gas will be bromine gas. Here I am taking up silver chloride, sunlight, and balance it. 2 chlorine, silver becomes 2. Here also it becomes 2. So you can identify that the question is, other in the form of question can be asked in this form also, that a white color compound is exposed to sunlight and we get a powder. which is of silver, which is a silver powder. Give the color of that compound. It is grey. Or give the name of the compound, silver. Type of chemical reaction, photolytic decomposition. Photolytic decomposition reaction means decomposition reaction using sunlight. And write a complete balanced equation. So this is the balanced equation. So I hope so. You all must have understood these important questions. They are asked in different ways, but the basic key is if we brush up all the basic concepts and then immediately go for the questions, so we will be revising whatever the concepts we have done, and this is the key to